Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is N-ary Tree Postorder Traversal. Okay, so you will be given the root of a N-ary tree, and you have to return the postorder traversal of its node values. Okay, so a postorder traversal is a traversal in which the children of the roots are processed first recursively, and then the node is processed. So what I mean to say is, let's say these are the children of a node. Okay, these red ones, and the yellow one is the root node. Okay, so these will be processed first recursively. Like, first of all, you will be visiting the first child, and then you will be seeing whether it's having some children of it or not. Then you will do these things recursively. So the first processing preference will be given to the children's, and this thing will continue recursively. Okay, so this is what a post order is. Okay, and we will also be understanding it with the help of an example. But before that, let's complete this problem statement. N-ary tree input serialization is represented in the level order traversal. Okay, so input will be given to you in the form of level order. Okay, each group of children is separated by null values. Okay, so as you can see, uh, 3, 2 and 4 are separated, are a group of children, and they are separated by null values. Okay, so let's take this example and try to understand how we can solve this. So what you will be given in your input is, let me show you uh, what things will be given to you as your input. Basically, it's just a way of saying that these nodes, children groups will be separated by null values, but actually you will be given your root value. Okay, and if we talk about root values, so this will be the form of your node. Okay, so each node will be having some value. Okay, and there is another property which is a list of nodes which represents its children's. Okay, so list of nodes, okay, which represent its children. So these two things each node will be having, and you will be given the reference of, or depending upon your language that you are using. So here reference of the root node. Okay, then you have to return the list containing the post order traversal of the given tree whose root have been provided to you. Okay, so these things will be given to you. Okay, now I think we should be clear about how implement it, how and what things are given to you, and how you have to think of it in terms of the input that you will be getting. Okay, so let me zoom in a little bit. Yeah, so I hope everything is clear till now, and let's see how post order traversal will be made for this particular tree, so that you have a clear understanding of the post order traversal. So let's say this tree is given to you, and the root of this tree will be given to you as input. Okay, so this will be your input. So what you have to do is, you have to first of all check, are there any childrens of this node. Okay, if there are some childrens, then you need to give them preference in the processing order. and one by one their values will be processed. So the first child is 3 of the root node. Then you will see, is 3 having any children? Okay, 3 is also having some children. Then we will be giving preference to them before 3. Okay, and then for 5 we will be checking, is it having some children or not? No, it's not having. So uh, since it's not having any children, we will add 5 to our answer. Okay, and then the next child of 3 was 6. So 6 is also not having any children, so then 6 will be added. Then the preference shifted to the current root, or in the recursive order that we are going in. So 3 will be given preference now. Okay, so similarly things will continue and you will get your answer 563241. Okay, so as you can see, we proceeded recursively. So first of all, we see for one, are there any children? Okay, there are some children. So pick the first one and do the same thing for it, considering it as the root of the current subtree. Okay, so this is what a recursive approach will be looking like. And if you want to see the implementation of it, let's see quickly see the implementation. Okay, let me bring the code to the board. So let's paste the code here. So this is the code for the recursive approach. Okay, so I hope is it's visible enough for you. So what we will be doing here is, first of all, as we discussed that we will be proceeding recursively. So this is the result that they were asking for, the list that will be storing the post order traversal. So we have declared it globally, and so that it is easily accessible by this helper function, and it populates your result. Basically it forms the post order. Okay, so you give the root to this particular function, and this is a recursive function. So what it does is, first of all, it check whether the current root is null or not. Okay, so if the current root is null, then it will return from there only. Okay, there might be a situation. Okay, and I forgot to discuss the constraints. So it is advisable to give priority to know the constraints also, so that you should be able to think of optimal solution for this one. Otherwise you may end up wasting your time, and your solution might be the one that is exceeding the time limit provided the given constraints. So you should definitely be considering checking the constraints first before thinking of an approach. So the number of nodes in the tree will be ranging from 0 to 10 raised to power 4. Okay, and nodes value will be ranging from 0 to 10 raised to power 4. Okay, and the height of the N-ary tree is less than or equal to 1000. Okay, and you need to pay attention here that 0 nodes can also be there in the tree. So the root that is given to you might be a null value. Okay, so this is for that kind of situation. To tackle that kind of situation, in that case you will be just returning an empty list. Okay, so if the root itself is null, then no values need to be inserted in this list, and it will be returned as it is without adding any values to it. Okay, so then as we talked about, recursively process the children's, and then only do processing of the root value. Okay, and then simply this recursion will do your work, and your result list will be populated, and you will be simply returning it. Okay, so this is one approach. Another approach is the approach that is asked in the follow up also. Recursive solution is trivial, could you do it iteratively? So let's try to do it iteratively. For that, what we will be doing is, see, we will just be simulating what the recursion stack was doing for us. Okay, but in reverse order. Okay, what I mean to say in reverse order is, so what we will be doing is, you will be processing your root first. Okay, then you will give preference to your children. Okay, so let me bring the implementation here in order to make this uh, solution video concise, so that it should not be very long, and we will be discussing how things are approaching in that particular implementation, although it's quite similar to that, but just that we are following the reverse order that we just took in the recursive approach. Okay, so let me bring the code to the board. So let's copy to the board to the next slide. So this is the recursive code. So let's zoom in a little bit. Yeah, I think this should be visible enough for you. So what we will be doing in the recursive approach is, so see, we need something to store our recursion nodes that we are currently not processed. Okay, so we need to replicate this or use similar kind of functionality of the recursion stack. That's why we will be using stack here. Okay, so it will be called node stack. So here in Java, I have used DQ for implementing stack functionality. It's a little bit faster than stack. Okay, so what will happen is, first of all, your stack will be empty. Then you will add the root to the stack. Okay, the current root that is given to you, and you will do a null check also, as there might be a situation where there are 0 nodes in the given tree. So you will be returning your result then and there only. Okay, this is the same result list that we were using in the recursive approach. So this one is iterative approach. Okay, and firstly, root will be entered into the stack. Okay, once you are having the root, you will do this operation when till when your stack is not having any nodes in it. Okay, node stack. So first of all, you will be popping the current value out of the stack. So the last value that was inserted will be obviously taken out. Okay, and you will be, once you have taken this value out, then you will be seeing is this value having any children or not. And before doing so, as I told you, in the recursive order, the preference was given to the children, but here the preference will be given to the processing preference will be given to the popped value. Okay, out of the stack. So you will add your current roots value, okay, to the result list. Okay, so you will be having your roots value to the result list, and then you will be processing your children. Okay, and then you will be adding your children one by one. Okay, and let's try to understand with one example. Okay, so let's take this one. It's a little bit small, so we will be able to easily traverse this with this particular algorithm. So first was 1, let me draw it here, then 3, 2 and 4, and then 5 and 6. Okay, so these were the values of the nodes. So first of all, 1 will be entered. Okay, so let's begin from the very scratch. So 1 is entered. You will enter this and see, is there any node in the stack? Okay, it's there is one node which is the root right now. So then you will pop that out of the stack, and this thing will be no longer in the stack, and it will be taken out. So it will be here. Okay, so you will immediately add its value to the result. So you will be forming your result. Okay, so let's remove this one. So here will be your results array. So you immediately edit its value. Then you see, are there any children of this particular node that we just popped out? So yeah, there are some children indeed. So we will be adding them. Okay, one by one. So 3, 2 and 4. Okay, once they are added, uh, then you will keep doing so until the stack becomes empty. So the stack is still not empty. You will do one another iteration of this while loop. Okay, so popping out 4, seeing whether 4 is having some children or not. Okay, no, it's not having. So 4 is uh, before checking its children or not, it's having children or not, you will just simply add its value. Then you will check, are there any children of 4 or not. Okay, so there were not there. So anyways, 4 is out of the picture. So 4 is gone. Then you will continue like this, and 2 will also be not having any children, so 2 will also go out of the picture. Okay, so 2 is also gone, and before that, before checking for any children of 2, 2 was added. Okay, and right now the turn comes for 3. Okay, so 3 value will be definitely added first before checking any children of 3. So you will be simply removing 3 and adding its value to the result. So its result value to the result is added. Okay, right now you will be checking children of 3 after adding its value. So yeah, it's having some children indeed, and they were 5 and 6. So 5 and 6 will be added. Okay, the stack is still now not empty. So one more iteration will be done. Okay, since it's not empty right now. So you will be seeing for 6, is 6 having something, first of all 6 value will be added and it will be popped out of the stack. Then 6 was not having any children. So then there is only one value remaining, which is 5. 5 will be added. Then you will be checking, are there any children of 5? Okay, they are not. So there are no children of 5. So right now your result array is looking something like this. But see, your actual result array was to look like this. Okay, so your result should have been this: 5, 6, 3, 2, 4, 1. So you can see it's in the reverse order. We got the list in the reverse order. So if you do a reversal, 5, then 6, then 3, then 2, then 4, then 1, you just have to simply reverse the list that you are having right now, and you will be returning it eventually. Okay, this is the iterative approach. And if we talk about the time complexity of this one and the space complexity, so it will be time complexity wise, you must have seen that we are processing each node only once, or okay, so you can say that, or we are doing a linear processing of nodes. So order of n time complexity, where n is the number of nodes. Okay, and space complexity wise, in worst case your stack might contain order of n entries. Okay, so space complexity will also be order of n because of use of that stack, even if we are ignoring the result list that we are using to store the nodes. Okay, so these are the complexities, and this one is the approach for iterative approach. And the recursive approach, I think we have already covered. This was the recursive one. Okay, and if you are not able to figure recursive ones complexities out, then please ask them in the comment section. And otherwise, I think we are pretty much done with the approach and the solution walkthrough. So if you are still having any doubts or any queries in general, then you may ask them in the comment section. And I really hope this solution walkthrough added some value to your journey of honing your DSA skills, and keep solving more and more problems. And I will be seeing you in the next video. Thank you for watching.